Alright, so welcome to Teaching a Computer my Conlang, a course where I will be teaching a computer my Conlang and hopefully you can follow along too. So yeah, this is going to be a very new thing for me. I've never done a streaming series before. I have never done videos this long, and I have never taught a computer my Conlang. So it'll be new for all of us. I hope it will be an adventure. I hope it will be a good adventure, and I hope at least two of you continue to watch these videos and follow along with me. I think it's going to be really exciting and fun. So what actually is this series going to be? What does it mean to teach a computer my Conlang? Basically, we're going to end up with computer programs that are going to translate from English to Dorini and back. And Dorini, by the way, is the Conlang I have chosen to do this with, and I'll get into why in a bit. And also to generate text in Dorini, and some other things maybe along the way. So yeah, as with any good Conlang project, we need to start with the goals. By the way, I'm on a Jupyter notebook right now. This is what this kind of file is. I'm using VS Code or Visual Studio Code. You definitely don't need to follow along with me, but I think you can, and that might be very helpful for you to do it with your Conlang. Also, I want to really emphasize that you don't need any coding knowledge for this series. I expect nothing. If you do have coding knowledge, awesome, and that might help you, and you'll be able to do more awesome things quicker, but there's no prerequisite knowledge. I also won't be explaining coding things in great depth, or general natural language processing things, which is kind of what we're doing. I won't be explaining them in great depth if I don't have to. I'll mostly just be focusing on things that you really need to know to teach a computer your Conlang. And yeah, this will require some coding, but I'll try to link the notebooks I'm using in the description, and so you guys will be able to follow along with your own Conlangs and maybe just like copy my code and change some things here and there if you really want to. But anyway, I do think it will help you learn NLP and computational linguistics more broadly if you want to do that. And if there's demand for more in-depth coding videos or NLP videos, I'll do that later. That is not what this series is for. So yeah, with all of those out of the way, let's get to the goals. Okay, so goal number one. I think the goal number one, our first goal should be to make awesome tools for my Conlang, or anyone's Conlang, right? Or your Conlang. So what awesome tools are we going to make? As I mentioned before, I think we're going to make a text generation model. Basically, this will generate text in our Conlang. We're going to make a translation model. Model, by the way, kind of just means computer program. The nuance of it are a little complicated and not really well defined, so I'm just going to be using it pretty much interchangeably. Also, I'll be using NLP and computational linguistics pretty much interchangeably. NLP stands for natural language processing. These are the tools that we're going to use to teach a computer our Conlang. So yeah, text generation model, translation model. And along the way, while we're making these, we're going to have to make some intermediary models, or we won't have to, but they'll probably improve our performance, which we want to do. And these models I think we might want to make a word generation model, a model to tell whether sentences are grammatical or not, and a model to tell whether words are phonotactically well-formed. Oh my god, well-formed or not. And this can be also represented as grammatically well-formed. What does grammatically well-formed mean? What does phonotactically well-formed mean? Grammatically, it's just like a sentence like green ideas sleep soundly. You know, it doesn't make any sense, but you know, you could see someone saying it, whereas green soundly sleep ideas, like that just sounds wrong, right? So that's the difference. The second one is not grammatical or grammatically well formed. It has nothing to do with proper grammar. It's just, you know, the kind of sentences we say. And that's all I'll say for now, but there's we'll probably get into that more in depth later. Phonotactically, this means that a word like start is an English word. A word like spart isn't an English word, but you know, we could see it being an English word. But a word like psrat obviously is never going to be an English word. So yeah, these are the models that we're going to build. This is our first goal. Second goal, learn natural language processing, or NLP, and computational linguistics more broadly. Also, I'm actually getting two birds with one stone here. I convinced my computational linguistics professor to take this as my final project. So I do want it to be submittable as a class final project. All this will mean though is that we kind of have to do some write-up at the end, but that's totally fine. So yeah, I think these are some pretty good goals. Next, we're going to get to why I chose Dorini. So why did I chose Dorini? Well, first, it's my most well-documented conlang. If you've been on this channel for a while, you know that I have tons of translation videos featuring Dorini. There's just a lot of Dorini text, and I don't have that much text in other conlangs. And this is really important. We'll see why in a little bit, but I think it just kind of makes sense. Yeah. Also, there are some typological features of Dorini which make it an easy language to teach a computer. And yeah, so certain languages are just harder to teach a computer than others, at least with the tools that we're using. So typological features of Dorini which make it easy, which make it easier to teach, are that there's zero agreement. So agreement is something that a lot of these programs classically have problems with, and Dorini has no agreement, so it can't have problems with that, so awesome. Also, the syllable structure and phonotactics are very simple. It's pretty much this. We'll get to that probably next video. But yeah, so these things make it pretty easy. Remove a lot of the potential issues. Also, and stress is non-distinctive, so we won't have to worry about stress. And the reason why we're worrying about syllable structure and phonotactics is because we're making this word generation model, and I'll say why in a second. So yeah, these are reasons why I chose Dorini. Next, there are some potential issues that are specific to Dorini. So there are also some potential issues that are not specific to Dorini, and there are going to be many of those, obviously. So we'll just see. So specific to Dorini. So in Dorini, you can commonly drop the topic from a sentence. So have a null topic sentence. And this is very common. It's also discourse based, which means it's based on the context. If you've said that word before in the conversation, and this is really hard to model on a computer. Like discourse, it's really hard to model on a computer, especially when you don't have a lot of data, and that will tie into some of the other problems we have later. But this is just really hard. So probably, I don't know exactly how we'll deal with this, but it's pretty likely that we just generate some models that produce extremely formal Dorini sentences. But maybe there is a way to fix this, and we'll figure it out. So I don't know, no presuppositions. So yeah, that's one problem. Another problem is that many words in Dorini have many different meanings depending on placement, and can be different parts of speech. Or phrase types, if you want to be syntactic about it. So like the word baba can mean hand or finger. It can also mean with, using, or like be an instrumental adposition, or it can even mean next to, I think. And I think it has a verbal meaning as well, maybe to help, but I don't remember off the top of my head. But a lot of words are like that. And it's kind of the affixes and the placement that tell you what meaning / part of speech they actually are. And that might pose a problem. I'm not totally sure yet. But the really big problem, probably the biggest problem, is specific to all conlangs. So this means it will almost certainly apply to your conlang as well, and that's sparsity. So sparsity is a terrible issue. Sparsity basically means that natural languages, or at least widely spoken natural languages, have so much text available on the internet compared with conlangs. Conlangs, yeah, I have a lot of translations in Dorini, like compared to other conlangs, but compared to real natural languages in the real world, it's incomparable. There's so much less text in Dorini than there is text in like English or Chinese or even less spoken languages. But there's just so much less text. And this is the issue of sparsity. So why is it a problem? It's a problem because how these models do their thing, which we'll get to here, is they need a lot of data. They learn from data. A lot of these models are AI, artificial intelligence, and we'll get to that in a bit, but they need a lot of data to train themselves on, to learn. And without this data, it becomes really hard to learn. So one potential issue, which I'll kind of outline, is in our translation model. Let's say we have a sentence like, I give my friend a piece of dirt, right? So the thing is, I don't think I've used the word dirt in any translation video, any text in Dorini that I've made so far. I just don't think this word exists in Dorini. I just haven't made a word for dirt. And in pretty much all conlangs, you know, there are just some words that you have never made a word for this word. So what does the computer do when it's given this sentence to translate, right? Yeah, it could just do whatever it thinks is closest. Maybe grass has a similar distribution to dirt. I know they don't seem that alike, but like, we'll get to why it might substitute dirt for grass and that kind of thing later. But basically, it just doesn't know what the word for dirt is, so it's not going to translate this right. How do we deal with this? The method I think I'm going to do for dealing with this is one that is not used all for natural languages, because they just don't have this problem usually, or at least they definitely wouldn't fix it this way. Because the way I'm going to fix it is I'm just going to, whenever the computer doesn't think there's a sufficiently probable word for something, this is a pretty bad definition, but we'll revise it. Whenever the computer doesn't think there's a sufficiently probable word for something like dirt here, it should come up with a completely new Dorini word. And so this is going to do two things. It's going to solve this problem, and it's going to provide a really nice, easy way of generating words in Dorini, which is awesome. They won't have cool etymologies or whatever. We can do that later if we want, but they won't intrinsically, but they will be there, and it will be cool. And this is why we need the word generation model, and therefore the model to tell whether words are phonotactically well formed or not. So this is what I want it to do. This is how we're going to solve the issue of sparsity. And maybe we'll run into, I'm sure we'll run into more issues along the way, and we'll deal with them as they come. So after you do the goals, you gotta, write what are the basic steps to doing this project. Step number 1 is always write out the basic steps. Because once we do this, we can check this off, and we've already done whole, part of our project. So we can feel good about it. So write out the basic steps, then make basic plan for each model, which I've already put down here. This just means like going through each model quickly and giving an overview of what the inputs and outputs are and generally how the model works. Very quick overview, very quick. Number 3 is make corpus. So a corpus is basically just a text file or multiple text files with a lot of text in Dorini or whatever your language is. And so this will just be like me going through all of the translations I have and copying and pasting. Or if I don't have the translations anymore because I lost the spreadsheet or something, that sucks. I'll just like transcribe it from my own videos. Yeah. So next we're gonna make all of the models. And this is gonna be the hard part, right? This is gonna be what almost all of our effort is spent. So we're gonna, I'm not sure of the exact order of this yet. So let's plan out the basic plan and then we can order them. 2.5, order models, or decide what order to make the models in. All right, so basic plan for each model. Okay. What should we do first? Let's talk about the text generation model first. Actually, I'll just go up here and copy paste my list of models. Yeah. Okay, so. All right, so for our text generation model, the input is actually only going to be the corpus. And the output is going to be never before seen text. How is the model going to do this? There are a few different ways it can do this, but we're going to start with and probably end with a next token prediction model. So what this means is a token in this context refers to a word. So basically, this model is going to start with something called SOS, which stands for start of sentence. Makes sense? So start of sentence token, it counts as a word in this context. So it's going to look at the start of sentence token, and then it's going to go through all of the corpus data. This is a simplification, but it's one that will probably help. It's going to go through all of the corpus data, and whenever it sees SOS, it will be like, what's after this? What's the next word? Or what's the next token? And let's say the is the word after SOS 90% of the time. So this means that 90% of the time we run our model, the next token is going to be the, and so on. Maybe that's a, or maybe it's as, so on. Let's say it's the. Then it's going to go look at what's the most common tokens after the, or maybe what's the most common tokens after SOS the. Maybe it's story, and then maybe it's is, or maybe another time it's dog, and then it's barks. Like, this is how it's going to work. And eventually, the dog barks. Maybe we have that. Maybe the next token is a period. We can treat punctuation usually as separate tokens or words. Maybe after a period, one of the common tokens is end of sentence. And so it does end of sentence and then the program's done. Or maybe it's end of paragraph or whatever we want to generate. But that's kind of how the next token prediction models generally work. And of course, I'll show you how to actually code this. Again, I'll just code it. If you don't know coding, that's fine. You can just download this Jupyter notebook and modify some stuff. So, translation model inputs. Depending on how we do it, this might differ. The translation model will definitely be the hardest model to make. We probably should do it last. The inputs are the corpus, maybe some version of the text generation model. That's probably, and of course, either the English or the Dorini sentence. And then it will output the linear English sentence, whichever one it can do. And maybe if we want some notes about it, translation notes, and so on. How does it do this? This is more complicated. There are a lot of different ways this could happen. I probably won't even get into it here. It's pretty complicated. Generally, we'll use a sequence to sequence model, which just means, yeah, sec to sec, sequence to sequence, which turns one sequence into another sequence. And it's pretty complicated how it does that, but you know, it learns. Both of these are AI, so both of these, they generate a ton of possible answers, they grade themselves, and the best answers win, and then they generate more answers like the ones that won, and so on, right? That's how they work. We'll get into how that actually works in code in a future video. Yeah. So then a word generation model. Inputs, corpus. Outputs. Actually, there are two ways we can do this. Option one is not with AI. So without using AI, we could just write a computer program. We could just write the syllable structure and phonotactics into the program. So we could just kind of code this using Python. Option number two is using AI, and our inputs would be corpus. And here we wouldn't really have no inputs. We wouldn't really have any inputs, and outputs would just be word or list of words in Dorini. Never before seen. Yeah. So for this one, the input is a corpus and the outputs are the same. And for this one, it's basically going to look at all of the words in the corpus and say, let's try, and then generate a bunch of random words and say how close are these words to the words in the corpus, with some more complexity that we'll code in, and then grade itself, go to the next generation, and so on. Very similar to the AI for these. Yeah, once you build one neural network or other AI model, the rest come easier, or at least for us with this. So yeah, how it's basically the same as the other ones. We'll get to that. So yeah, that's our word generation model. Then we have these last two models, and these we probably don't actually have to describe these that much. These are pretty simple. These basically take in as an input a sentence or a word, and output yes or no. Yes, it is grammatical. No, it is not grammatical. Yes, it is phonotactically well formed. No, it is not phonotactically well formed. Yeah. And so the reason why we need these is, well, one, they're cool on their own right, but two, they might help us within these models to verify our outputs. Maybe we can say that we run our outputs of these models, the translation and the text generation models, when we're translating to Dorini. We run these outputs through this, and if this says, no, that sentence is not grammatical that you've just made, then it just looks for another output, and so on. Same with words. Wow, so that's that. That's the basic plan for each model. We wrote out the basic steps. I think I have a check mark keyboard shortcut. I'm not totally sure what it is, but it's, oh, all right. Check mark. So we're done with the basic steps. We're done with making basic plans for each model. Oh my God, we're already halfway done with this whole project. We now need to decide what order to make the models in. I think the order should be, wait, that's the wrong thing. The order for making each models. Okay. I think first, we should make the word generation model maybe option 1. So that's the non-AI, because doing something that's not AI will help us get situated with Python and that kind of thing. And even if you already know it, and then we'll go on to option 2, because that just makes sense. And option 3, wait, there is no option 3. What's the third thing that we should do? I think probably we should go to this model, because it just has to do with phonotactics, and we will have been doing that a lot. Yeah. Then maybe we go to either this one or this one, the text generation model, or the test whether sentences are grammatically well formed model. I think we probably should do this first, the text generation model, and then this model, because we won't really see what issues we'll have until we actually start generating sentences. Nope, that's not 4, that's 5. This is the text generation model. And then lastly, of course, the translation model. Yeah, and this will be pretty hard, but I think we can do it. Also, ending on a caveat that some of these models will probably not be that good. I really have never done this before, obviously, and we're just gonna hope. But I think they'll make cool things no matter their actual performance quality, or yeah. Yeah, so that's the first episode of Teaching a Computer My Conlang. I hope you enjoyed it. I hope you watch future episodes and join me on this journey, and comment, of course, if you have ideas or have ideas for the series, or just want to tell me how it's going with your own conlang. I would love to hear that, and it will probably give me ideas as well. So yeah, thanks for watching.